Hello students. So in this video, let us focus on the general preparation techniques and the uses of acids as well as the chemical reactions of acids. So first of all, how to synthesize acids. So we all know that acids contains one of the principal element, which is hydrogen. So by the direct synthesis from hydrogen reaction with non-metals, we can synthesize acids. For example, look at here, hydrogen gas directly reacts with non-metals gases to form the respective acids. Hydrogen gas plus chlorine. So what is the acid we can expect? Hydrochloric acid. Hydrogen gas plus bromine. So what is the acid we can expect? Hydrobromic acid or hydrogen bromide HBr, or like HF, hydrofluoric acid, or hydrogen with sulfur to produce hydrogen sulfur. Directly by the reaction of non-metals with the respective hydrogen gas, we can synthesize all these acids, as well as by dissolving non-metallic oxides in water. So you already know that non-metallic oxides are acidic in nature, yes sir, students. And when these non-metallic oxides, when they dissolve in water, what do they produce? They produce the respective acids. For example, carbon dioxide is a non-metallic oxide, right? When it dissolves in water, what does it produce? Carbonic acid, H2CO3. Sulfur trioxide, SO3, it's a non-metallic oxide. When it dissolves in water, it forms sulfuric acid. Like nitrogen dioxide forms nitric oxide, nitric acid, as well as phosphorus pentoxide, and it forms phosphoric acid. Like you can see all these examples, all these non-metallic oxides, when they dissolve in water, in general they produce oxy acids, and you can see the combinations, and they produce a respective carbonic acid from carbon dioxide, so sulfurous acid from sulfur dioxide, sulfuric acid from sulfur trioxide, as well as nitric acid, nitrous acid from nitrogen dioxide, and phosphoric acid, phosphorus acid from phosphorus pentoxide. Ultimately, these acids can also be generated, can be produced from the respective non-metallic oxides. Why? Because they are also acidic in nature. So properties of acids, like properties means we have two types are there. One is physical properties and chemical properties. So when it comes to the physical properties, students, first taste. Acids, all acids have one characteristic taste, that is acids are sour to taste. All the types of acids are sour to taste, and acids are corrosive in nature. That means they burn on the material, whatever the material they fall on. So they are corrosive in nature. They destroy materials like human skin, wood, paper, fabrics, metals also, students. That's why while dealing with these acids, especially concentrated acids, you have to be very careful. So they directly eat away the skin if it falls on the skin. Even they can even corrode the metals also. That's why in the uses of metals, these acids, especially nitric acid, is used for etching of metals. Like etching means to make some kind of artworks on metals also. Because of the corrosive nature of acids, we can use acids for that property. Even fabrics, paper, everything, they are very corrosive. So acids are generally soluble in water, right? This is very true in general. That's what acidic behavior is. So students, when they dissolve in water, they produce H plus ions in their aqueous medium. So they are absolutely soluble in water, and acids turn blue litmus paper to the red. So this is litmus is an indicator in order to identify whether a particular solution is an acidic or basic. In acidic, what is the color change? Blue to red color. In basic, red to blue color. As well as these acids, even in phenolphthalein also. Phenolphthalein in acids are colorless, in bases show pink color, and methyl orange, acids are red in color, bases are yellowish in color. So the solutions of acids in water are good conductors of electricity. For the conduction of electricity, what is necessary? The free ion, students. So when acids are dissolved in water, they release H plus ions. If H plus ions are released, there are the respective opposite ions also there. So students, so these ions are carriers of electricity. So that's why the solutions of acids are good conductors of electricity. And acids turn methyl orange to red, that we already discussed. So all these are the indicators just to identify whether the solution is an acidic or basic. So chemical properties means how these acids react with other elements like metals, oxides and all. So first of all, action with active metals. Acids, when they react with metals, this is a common thing for all the acids. Remember, they release hydrogen gas. When acids react with metal, they produce the respective salts and they release hydrogen gas. So look at here in the given example, aluminium. Aluminium reacts with hydrochloric acid and it produces aluminium chloride. And what is the gas released, students? Common hydrogen gas is released. And what is the identification technique for the hydrogen gas? And if you keep any burning matchstick near to it, it just put off with a pop sound. That's the identification. Here the metal is taken as aluminium. Instead of aluminium, if you take zinc, zinc reacts with HCl and produces ZnCl2, zinc chloride as well as hydrogen gas. If you take sodium, sodium chloride, hydrogen gas. If you take magnesium, magnesium chloride, hydrogen gas. Not only hydrochloric acid, if you take any acid and if you take any metal, what is the common gas getting released? Hydrogen gas and the respective metallic salt. It depends upon the type of components we are taking. So got the clarity, students, with metals. And reaction with metallic oxides. So metallic oxides are basic in nature, like we discussed in the previous slides. Non-metallic oxides are acidic in nature, metallic oxides are basic in nature. Now acids, when they react with metallic oxides which are basic in nature, you expect what are the components which are produced? Salt and water. Yes or no? When acid react with base, what do we get? Salt and water. So here also, like sodium oxide is a metallic oxide, is a base, right? When HNO3 is a acid, nitric acid. When these acids react with this metallic oxide, we can get the respective salt, which is sodium nitrate and H2O. Salt and water are produced. This reaction is called as neutralization reaction. So take any acid, take any metallic oxides, in general they release the respective salt as well as what is the common thing? H2O is produced. So this is the reaction with metallic oxides. And action with metallic hydroxides. Metallic hydroxides are direct bases according to Arrhenius, which have capability to release OH minus ions. No? Sodium hydroxide, magnesium hydroxide, potassium hydroxide, all these are hydroxide. Here we have copper hydroxide when it's weak base. In reaction with sulfuric acid when it's strong acid, what do we get? The respective salts. So how to identify the respective salt? Double displacement reaction. Copper is the metal. Based on the combination, you should identify the valency of copper. Here it combines with 2 hydroxide. That means what is the valency of copper? 2. On each hydroxide minus 1, yes or no? And in the sulfuric acid, what is the negative radical? Sulfate, SO4 minus 2. Now Cu plus 2, SO4 minus 2, in what ratio they will combine? 1:1 ratio, which forms CuSO4, and the resultant molecule is H2O. You ultimately have to write the balanced chemical equation. So the point to be remembered in this reaction is, when these acids, when they react with hydroxides, which is a base, acid react with base, produces the respective salt and water. How to write the respective salt? Also we discussed about finding the valencies of the respective metal in the given components. So next, action with metal carbonates and bicarbonates. This also very important in the exam point of view, students. When acids reacts with metal carbonates or bicarbonates, they release one common gas, that is carbon dioxide. CO2 gas will be released. You can check in both cases. What is the common gas? When acids reacts with metals, they release hydrogen gas. When acids react with carbonates or bicarbonates, they release carbon dioxide. What is carbonate, students? CO3 minus 2 is carbonate. What is bicarbonate? HCO3 minus is bicarbonate. So here, look at the examples given. Potassium carbonate, K2CO3, and KHCO3, potassium bicarbonate. So when these two react with any acid, here it is taken as HCl and HNO3 respectively. So when they react, they produce the respective salt. Here HCl is reacting with K2CO3. So what is the salt expected? Potassium chloride only. Here HNO3 is reacting with KHCO3. So what is the salt can expected? Nitrate salt, which is potassium nitrate, and H2O as well as carbon dioxide gas is released. So this is the point to remember, and how this is the point to be remembered. And what is the identification technique for the carbon dioxide? CO2, when it react with calcium oxide CaO, and it turns the water milky, the solution milky, because of the production of calcium carbonate. This is the identification technique for CO2, students. So these are the reactions with carbonates, metals, metal hydroxides, oxides. Now uses of acids. There are many uses of acids, yes or no? So the common organic acids, for example citric acid, tartaric acid, where do we use all these acids? Like for fruits, we used to eat all these, which are good for lactic acid, milk, yes or no? For a biological system also it is good. So some mineral acids and their uses also we'll discuss in this slide. Acids have several uses, mostly industrial uses, students. Acids, different acids are used for different purposes, yes or no? So first of all, vinegar. Vinegar, what it is made up of? Acetic acid, which is CH3COOH, is used in the kitchen as a liquid containing 3 to 6% or 3 to 8% on sometimes acetic acid. It is used in pickles and in many food preparations. So students, 3 to 8% means remaining is water, and this percentage of acid is present in that solution. Where it is used mainly in the kitchen for the flavor enhancement is this acetic acid is used. Vinegar is the most common thing which we all know in the kitchen. Yes or no? It is used in the pickles as well as many food preparations, many food preservatives also. This vinegar is used, students. So lemon and orange juice means we all know the use. Contains citric acid. Citric acid is used in the preparation of effervescent salts and as a food preservatives also. So mainly citric acid is used as a food preservative, and effervescent salts means, effervescence means escaping of bubbles, water bubbles, gas bubbles from the particular solution. So these effervescent salts are mainly used in the medicinal field. For example, to create some kind of tablets for gastric problems and all. So there we use this lemon and orange juice mainly contains citric acid, that is the use of citric acid, as well as food preservatives also. Acids have been put to many uses in industries. Nitric acid and sulfuric acid are used in the manufacturing of fertilizers, dyes and paints, drugs and explosives also. So the salts which are produced from these sulfuric acid and nitric acid, for example, potassium nitrate coming from nitric acid, it is used as explosive, and ammonium sulfate, it is used as a fertilizer. So not only fertilizers are explosives, they are also used as coloring agents in many dyes and in many paint industry, for washing, for cleaning purpose also. All these acids are being used, students. So next, sulfuric acid is used in the batteries also, students, one of the electrolyte in the battery which are used in the cars, etc. Tannic acid is used in the manufacturing of ink and leather, preparation of leather. So all these acids are used. Not only here, students, preparation of in organic synthesis, in organic for the preparation of organic reactions, all these acids are used as an reagents. That means these acids, what is their capacity? They can release H plus ions. These H plus ions can initiate the reaction. Some type of acids are acts as oxidizing agents also, like nitric acid. So for these, this role is called as a reagent. So they're also used in the organic synthesis also. Hydrochloric acid is used to make aqua regia, which is used to dissolve noble metals such as gold and platinum. For metallurgical process, for extraction of that metal also, the acids are used: aqua regia, hydrochloric acid and nitric acid combined in 1:3 ratio, students. So sulfuric acid is used in the manufacturing of fertilizers such as superphosphate and ammonium sulfate, like we discussed just now. So the majority of the fertilizers are coming from nitric acid and sulfuric acid only, not direct acids. They are salts which are produced from the respective salts, like ammonium nitrate, ammonium phosphate, ammonium sulfate, and all these are mixtures of these salts can be used as a fertilizer. One of the key component for the growth of the plant is nitrogen, phosphorus, students, and potassium also. So these salts are being produced from these acids. So these are the general uses of all these acids. So what we discussed in this video, we discussed about the preparation techniques of acids and physical properties of acids, chemical reactions of acids, as well as uses of acids. So that's all for today in this video, students, and our coming discussion is about bases that we'll cover in the next video. So thank you, students.